Good afternoon. My name is Philip Franklin, and today I will be showing you a presentation on thermal physics. And the title is going to be Objects that Revolve Around Conduction, Convection, and Radiation. Today we will be discussing what is heat transfer in thermal physics. We will be defining and distinguishing the three different types of thermal physics that deal with heat transfers. And each of these three, and after discussing the three different types, we'll be giving examples and discuss each of the three different types of thermal physics of the heat transfers. So first, we must discuss what is a heat transfer in thermal physics. In thermal physics, heat will always move from a warmer place towards a colder place. And hot objects in a cooler room will cool to room temperature, and cold objects in a warmer room will heat up to room temperature. And there are three different types of heat transfer methods that we will be going over today. And those three are conduction, convection, and radiation. I chose this picture as a good example, as you can see all three forms being used. So first off, we're going to talk about conduction, that is on the bottom left side. And you can see the individual is using a stick for the fire. And you can see as the stick gets closer to the center of origin of the flame, the hotter the stick is. So on the far right of the stick, you can see how hot it is. And on the far left, you can see how cool it is, as there is no temperature going towards that individual's hand. So you can see how the heat transfers from that one side of the object to the other. Convection is shown as heat always rises to the top, and the lower temperature will rise back to the bottom. So this person that has their hand on top of the flame is always getting heat to their hand. And finally, on the far right, you'll see this person putting their hand kind of close to the flame, and they are using radiation. They are getting hot air from the flame itself. So first off, we're going to talk about conduction. Conduction is the process in which the heat or electricity that is directly transmitted through the substance when there is a difference of temperature. If there are any changes between the adjoining materials or two objects, then there will possibly be no chance of conduction ever occurring. There are many factors that go into conduction. In conduction, the factors are the following: temperature gradient, cross-section of material, length of travel path, and physical material properties. In these four factors that I just mentioned, temperature gradient, length of travel path, and physical material properties are the main three. So temperature gradient is solely depicted on how that temperature of hot air or hot electricity can be transferred through the object because of the physical material properties. And this could be depending on if it is highly dense, less dense in those properties, and depending on volume and surface area. And then the length of travel path is depending on how far the heat or electricity has to be transmitted through it. So here are some examples of conduction. So one example that I'm going to give you is when you are in the kitchen cooking food on the stovetop. The individual can place their hand onto the stovetop, and there will be a change in temperature between both, as the stovetop will have hotter particles than the individual's hands, as the heat conduction has a higher concentration of particles tightly packed together to increase the temperature. In the bottom left corner, I can show you there's heat source of the stovetop on the bottom, and then you can see the pan. That heat will rise through the pot due to its physical properties, and then after a few minutes, heat will begin to go onto the pot, and the pot will begin to heat up. Another example of conduction, depending on its surface area in which it has to travel through. If you put a pot onto a smaller burner versus a larger burner, the smaller burner will get the pot a whole lot faster than if you were to put the pot onto a larger surface area. This is because there could be heat loss through this transfer. Moving on, we're going to talk about convection. Convection is the movement caused with a fluid that is hot, and the heat due to the less dense material will cause the heat to rise. If the temperature is cold, the fluid will sink due to gravity and the material being dense. As the temperature increases due to the given fluid, the volume of the mass must increase as well. If not, heat transfer loss will occur. The hot heat rises up and warm air is released into the air to allow heat into the area of the house in which the object is placed at. So we're going to give examples of convection. So using the same method of the pot or pan used on top of the stove, this time we are going to put water into it. And we are going to change the temperature of the stovetop to maybe high, just so we can get the water to boil. And the bubbles that an individual sees at the top of the heat is hot air rising. And the cooler temperature of the water travels back down to the bottom of the pan until that part becomes heated and rises back to the top. So this becomes a continuous convectional current. As heat rises and the cooler temperature water falls back down, and then the whole process continues until the process is stopped. Another example is going to be using a lava lamp. In a lava lamp, there is oil, water, and a light bulb. The light bulb is going to be the use of heat in this scenario. At the bottom of the lava lamp, the light bulb will heat the oil that is within the lava lamp. The oil is going to start at the bottom, and as the oil starts to get heated up by the light bulb, the oil will then expand and then rise. So that is how you will see the continuous flow of the lava lamp, of the oil rising up and then falling back down. As it rises, that's where the heat is going, and as the temperature dissipates because of the light bulb being at the bottom of it, not as much heat can be produced to the top. So that's where you will see oil fall back down to the bottom, and that process will start continuous again until the light bulb is turned off. The last example that I'm going to use for convection is a space heater. A space heater is used during cold winter months, so then the room can be heated for a family. The space heater, as you can see here, hot air will rise, and as that air rises, it produces warm air for the family, and the cooler air that is within the space heater falls back down due to its gravity, and then the same process begins again with the convectional current, as the cold air will go back, get heated up, and then as the temperature of it rises up, then it releases warm air. And last but not least, we're going to talk about radiation. Radiation is the heat that is generated through the emission of electromagnetic waves that occur within the object. It creates heat as the energy is being dissipated off of the object by the direct result of random movements of atoms and molecules and matter. So in radiation, this has more random movements of atoms than any of the other two that we discussed with convection and conduction. This radiation is more like the gas particle in matter, and convection and conduction are more like the liquid. So here are some examples of radiation. One simple example is going to be the sun radiates heat onto us on planet Earth. And then the other one is going to be solar panels on top of a house. So for the basic example of the sun always radiates its heat onto us depending on its location and other factors that are happening on Earth. So the sun will always radiate heat onto us, and the cooler air that will be dissipated off of planet Earth is when the sun goes down, and so this process starts over and over each day. So as the sun produces heat onto us, planet Earth will reflect its sun's energy overnight. And for the solar panels use radiation from the sun to produce heat energy for the house. In the house, it produces energy for anything electronics, appliances, or any other items within the house. And this is solely needed from the source of the sun. When the sun is not directly putting its hot air onto the hot energy onto the solar panels will have to use its energy and resources depending on the family and what they need until the sun comes back out. In conclusion, in thermophysics, all three are essential even though they have their differences. In each part of thermophysics, there was an example of each given with real-world environments interacting with each. In physics, each can be essential as heat is needed to create energy. These are my references. And thank you, and have a great day.